like this.
Fine. I think now you can go to the slide share option.
Can you see the slide now?
I can see the slide here.
Okay, wait a second.
No problem.
You can see the slide now?
Yeah, I can. I think there's some problem with the fourth slide. The snip, I think, moved out of the frame.
Oh, shit. Okay. Got it. Okay, so let's start, okay?
Fine. I just wanted to ask you, our team number is 3, right?
Okay, we can add that. Do you know what's our team number?
Yeah, I was just confirming from you, but one second, I'll check. I'm not sure.
Here's team 3. I mean, we got it.
It's team 3?
Yeah,
Okay.
we got it.
Fine.
Sure, let's go. So we are recording now, right?
Yeah, you can cut this part and then I can just start.
Yeah, sure, no problem. Okay.
Hi, we are team 3 and I'm Wesley. Will be taking you through the assignment 4. So starting with the first question, in this question, the objective was to replicate the results in the Schum-based paper using the CompuStat and CRSP databases. The first step was creating the firm dataset, and that involved extracting the data from CompuStat and CRSP. So instead of the Schum-based sample period, we extended the sample period to 2020. At the end of this step, we end up with a data table that's firm data that consists of information of about 23,000 firms with nearly 250,000 rows of firm year data with 14 columns, which are grouped by a unique identifier for a particular firm and by their fiscal year. Now, coming to the step 2, that involved reading in the failed firms and the bankruptcy years that they filed bankruptcy. That was provided. And in step 3, we created the status variable using the information in the failed firm to create a variable in the firm data to indicate if a firm filed for bankruptcy or not. Now, coming to the step 4, we created a training and the test set. And in the training set, it contains all the firm year data from 1962 until 2002. And in the test set, there is all the firm year data for the firms with data from 2003 to 2020. Now, coming to the first part of the question, we found that in the training set, there were 160,673 firm years, and out of that, 466 firms failed. And in the test set, there were 78,946 firm year, and out of that, 270 firms failed. And now coming to question number first, second part, where we were asked to compare the Altman's variables using the one-period logit model and the multi-period logit model, where we found that the multi-period model performed better and had a area under the curve of 0.82 as compared to the one-period logit model, which had the area under the curve of 0.77. Now, Wesley will be talking about the next part of question number 1.
Okay, so wait a second. I thought you were gonna talk off the question 1.
Oh, sorry. I can talk about that if you want.
Oh,
It's just reading.
yeah. So, I mean, we need to restart it, or I don't know.
Do you want me to restart? What do you want me to do?
I don't know. Can you restart it, because I don't know how to cut the video together.
No problem. I'll restart.
Yeah, I'm sorry for that.
No. So I'll do all the first question and second question completely then, right?
Yeah, I thought you were.
Okay. I thought it was like first A and B, but anyway, it's fine. I'll do it again.
Yeah. Okay. I'm sorry.
No problem. Hi, we are Team 3, and I'm Wesley. We'll be taking you through assignment 4. The first question, the objective was to replicate the results in Shumway's paper using CompuStat and CRSP databases. In the first step, we were asked to create a firm data set, which involved extracting the data from CompuStat and CRSP And then we extended the sample period to 2020. At the end of the step, we got a data table that's called firm data, and that consists of information of about 23,000 firms with nearly 250,000 rows. And there were 14 columns that was grouped by the unique identifier for each firm and by their fiscal year. Now, coming to step 2, we read in the failed firms and the years that they filed bankruptcy in. And in step 3, we created a status variable. We used the information that we got in step 2 to create a variable in the firm data to indicate whether a firm filed for bankruptcy or not. Then coming to step 4, we created a train set and a test set. The train set consists of data for all the firm year data from 1962 until 2002. And the test set consists of all the firm year data for the firms with data from 2003 to 2020. Now, talking about the first question, A part, we found that in the training set, the number of firm year was 160,673, and out of that, 466 firms failed. And in the test set, the number of firm years were 78,946, and out of that, 270 failed. Now, coming to the B part, where we were comparing the alternate variable using the one-period logit model and the multi-period logit model, we observed that the multi-period model performed better with AUC of 0.82, and as compared to the one-period logit model with area under curve of 0.77. Now, in the C part, we were asked to create another status variable where we saw similar results where multi-period model performed better than the 1 year period. The same was observed in creation of other status variables where, again, the multi-period performed better with the AUC of 0.92 as compared to the one-period logit model with AUC of 0.90. And we also saw that the Schum-based variables that were there in question D, where the multi-period had the highest AUC of 0.92. Now, coming to the second question. In this question, we are working with the Randleman-Bartner model. It's also called the Bloomberg Fair Value model, and it is an interest rate model which follows a similar process as the Black-Scholes model for the stock prices. Here, the objective of the question was to find two parameters, that was a lambda and sigma, to calibrate the model. So we started with a set of hypothetical values for lambda and sigma. For lambda, we took 0, and for sigma, we took 0.01. Post that, we built the probability tree and the spot rate tree. As we know that in this model, the probability, it remains the same, and that was given by the formula e to the power of lambda into delta t minus t divided by u minus t. Then we use the spot rate tree that we got in the last step to make a function to calculate the price of 1 to 10 year zero coupon bonds. Using this zero coupon bonds, we then calculated the model spot rates, and then we compared the model spot rate with the observed rate to find the sum of squared errors. After we found the sum of squared errors, we used the Optimax function to minimize the sum of squared errors to find two parameters, which were lambda and sigma, and from there we got lambda and sigma values, which were 0 and 0.0065. And now Wesley will be taking you to talk about question number 3.
Okay, so now I'm talking about the question number 3 now. For the question number 3, first of all, we need to build a data table for our payment for every different kind of period now. And second, what we do is we need to read the Libor rate and also the euro dollar future together. And for the euro dollar aspect, we need to filter out the March, June, September, and December month in this time. And later on, step 3, what we do is about the interpolate 3-month forward rate for the end of each quarter. Why we do this? Because this can help us to find out the number about the payment amount for each of the period. Step 4, what we do is about interpolate the stub rate for the Libor rate, and because we want to interpolate the settlement date to the period 1 day now. So the last part is now we have this chart for those numbers. We multiply the payment amount with the discount factor, and we can get the present value for each of the period time. And later on, we will sum up together to get the final value about the sum one. And this is about the question 3 here.
I think we're done.
Yeah, I think we're done. Okay, so one more question. Do you know I just end up this and I will got the video, or?
I think I don't remember exactly from the last, but once you end